Guys, this is Salim Musa Jalbani, and I'm going to be doing a full review of the test 2 theory section. So let's just go over the questions. The maximum useful output power P of the car traveling on a horizontal road is given by this expression. We can see that, where V is the maximum speed of the car and B is a constant. For the car, the power is given with its percentage uncertainty. You can see that, and also B is also given with the percentage uncertainty. Your target is to calculate the value of V. Now, since the question is only asking us about the value, we need not concern ourselves with the percentage uncertainties or absolute uncertainties for that matter. We'll simply just find out the value of V. So 84 multiplied by 10 raised to power 3 should be equal to, I did this because kilo is apparently 10 raised to power 3, and this is going to be V cube multiplied by B, which is 0.56. Okay, so let's just find the value. I'm just going to input the values into my calculator and see what happens. In 84 into 10 raised to power 3, and we are going to divide this by 0.56, and I'm just going to take the cube root of this entire value. So shift, and I have this function on my calculator, so I'm just going to find it out directly. And this value of V is coming as 53.1. okay, since the values that were given to us were up to 2 significant figures, so I chose to code the answer up to 3 significant figure. You know, you can always increase the significant figure by 1 from the bare minimum. Anyways, determine the absolute uncertainty in the value of V. Now your target is to determine the absolute uncertainty. So let's just go over all this. So this is going to be V cube is equal to P divided by B. And now we have this power over here. So first of all, I'm just going to be applying the cube root on the right hand side. This is going to be P raised to power 1 over 3. Apparently cube root is actually 1 over 3 raised to power 1 over 3. So I'm just going to be doing that. And B is also raised to the power 1 over 3. Okay. So your target is to find the absolute uncertainty in the value of V. So first of all, we already have the percentage uncertainties, and we know this, that whenever there is multiplication or division involved in a question, you always add the percentage uncertainties, but be careful with the powers. Okay, these powers will be multiplied by those percentages as well. So luckily we have the same power for both, and we can simply just do it in one single operation. So percentage uncertainty in V should be equal to percentage uncertainty in P. I just need to multiply this by 1 over 3 as well. 1 over 3 multiplied by the percentage uncertainty in P plus 1 divided by 3 into percentage uncertainty in B. Okay. So what are the percentages? Once again, in P we have the percentage uncertainty as 5, and we have 1 over 3 multiplied by 7% in B. So let's just quote this value. This was a very simple question. So 5 divided by 3 plus 1 divided by 3 multiplied by 7, and the answer is 4%. I mean, it's actually absolute uncertainty is plus minus 4. Okay, so this should be the answer up to 1 significant figure. We only have to quote the answer up to 1. So no. I just think this is the percentage uncertainty, but we also require the absolute uncertainty. I just made a mistake over here. I did not reach the conclusion. So this is actually 4%. Now we need to find the absolute uncertainty. So absolute uncertainty in V must be equal to 4% divided by 100 and multiplied by the value that we got was actually 53.1. So let's just multiply this thing. So 4 divided by 100 and multiply by 53.1, and this value is coming to me as This value is coming as plus minus, I'm just going to be rounding this off, so this is going to be plus minus 2. So the absolute uncertainty is plus minus 2. Okay, so this question is done. You will definitely score 4 marks if your working resembles something like this. Anyways, let's move on to the next question. A spherical balloon is filled with fixed mass of gas. A small block is connected by a string to the balloon as shown in figure 2.1. Okay, so we can see that. The balloon continues to lift the block. The string breaks as the block is moved vertically upwards with a speed of 1.4 meter per second. After the string breaks, the detached block briefly continues moving upwards before falling vertically downwards to the ground. Okay, after the string breaks, the detached block briefly continues moving upwards. It is obviously, it's a fact. It's like the block will continue to rise. It will not simply just fall down immediately upon disconnect. The block hits the ground with a speed of this. I'm so sorry. Assume that the air resistance on the block is considered negligible. By considering the motion of the block after the string breaks, your target is to calculate the height of the block above the ground when the string breaks. Well, let's do some working over here. Once again, the string breaks as the block is moving vertically upwards with the speed. I'm just going to be highlighting the important points. Okay. After the string breaks, the detached block briefly continues moving upwards before falling vertically downwards. The block hits the ground with a speed this. Okay. So the information is that we need to find the height of the block above the ground when the string breaks. So let's say the block reached this particular position when it was connected with the balloon and then it was disconnected. So it had a brief period when it actually rose above that height and then it fell all the way down. Okay, so this is my main question and my target is to find this height. My target is to find this height. This is the height that I require. So for this part, what we can do is that we can find this height and we can also find this final height and we can subtract the two heights to find the answer. Okay, so this is exactly what we are going to be doing right now. Oh, that makes perfect sense. Or you can take the vector approach and solve it directly, because it's just the displacement that we require. We can do that, but for that we would be needing the time. But we don't need the time. We already have it. Let's apply the vector approach using pure vector approach. Apparently when it got disconnected, the speed was 1.4 meter per second, and I'm going to be taking upwards as positive, so I'm just going to assign this. So initial speed is 1.4 meter per second. The final speed upon hitting the ground is actually 3.6 meter per second. And we happen to have the value of acceleration as negative minus 9.81 meter per second square. Okay, so therefore we have three physical quantities are with us, and now we can find the fourth quantity, which is the displacement that we require. So S is equal to H, and we can go for V square is equal to U square plus 2S. We don't need the time. So the final speed is actually 3.6, but this value of 3.6 should be negative. Okay. The reason is that because upon returning, the velocity is going to change direction, so this is going to be negative. So minus squared, but it doesn't matter because we have a square on it, and this is equal to u square, which is 1.4 square, plus 2 times the acceleration. The acceleration is minus 9.81, and we have the height h. Okay, so let's just find it out in one single operation. And this is going to be 3.6 squared minus 1.4 squared, and I'm just going to divide it by 2 into 9.81. Obviously I'm just going to keep the denominator in complete brackets. and the value of h that I'm getting is, the value of h is actually positive 0.56 meters. Okay, so this is one way to approach this question. The other way is that you have to find this height first and then this height in the second part, and then you will have to subtract the two height, but it is going to take a long time for the solution to be there. Anyways, this question is done, so the answer should be around 0.56 meters. Let's move on to the next part. Now the question says the string breaks at time t is equal to 0 and the block hits the ground at time t is equal to t. Okay. On figure, sketch the graph to show the variation of the velocity v of the block with time t from t is equal to 0 to t is equal to t. Numerical values of t are not required. Assume that v is positive in the upward direction. Okay, so v is positive in the upward direction, and we need to draw this line over here because the acceleration is actually kept constant. It was already assumed. So let's see. Let's think over it. Assume that v is positive in the upward direction, so it was initially positive, so 1.4. I'm just going to mark this. 1.4 is going to be somewhere over here. This is 1.4, and it becomes equal to 3.6 when it hits the ground. So negative 3.6. So this is going to be, this line is actually 3, so 3.2, 3.4, 3.6. so we will have a marker over here, and I'm just going to erase this line, and we will just draw a straight line because the gradient will not change because it is equal to the acceleration due to gravity, and it will always be negative and constant. So I'm just going to be drawing a straight line. I'll be using a red color to display the line, and it is going to be somewhat like this. Okay, so there you have it. This question is done. It's a 2-mark question, and it was quite easy in my opinion. Let's move forward. Okay guys, so we have another question. A man standing on a wall throws a small ball vertically upwards with a velocity of this. We can see that the ball leaves his hand when it is at a height of 3.1 meters above the ground as shown in figure 3.1. We can see that. Assume that the air resistance is considered negligible. Show that the ball reaches a maximum height above the ground of 4.7. Okay guys, so we need to find the maximum height, and for this we already have one of the heights given over here, which is 3.1 meters. We only need to find the rest of the height which is reached after the ball travels upwards from this point. Okay, so it's going to be traveling upwards like this, and then it will reach its maximum height and then fall down. We need to find this height and add it to this value. Okay, so this seems like an easy part, so let's just pull this off. So let's see, initial vertical velocity is kept as 5.6 meters per second. I'm going to take acceleration as negative because upwards the ball is going to be slowing down. So this is going to be minus 9.81 meter per second squared, and the final velocity at the maximum height would be 0. This is enough information for us to find the height that is reached. So we are going to be using v square is equal to u square plus 2s, and let's see, the final velocity is 0 squared and the initial velocity is 5.6 squared plus 2 times the acceleration is minus 9.81, and the height s is something that we need. Sorry again. So this is going to be 5.6. Okay, so this is going to be minus brackets 5.6 squared, and we will divide this by 2 into brackets minus 9.81, and the value that I'm getting is 1.6. I'm just going to round this off to 1.6. Okay, so this is the remaining height. So this is actually 1.6, And if we add the two values together, so this is going to be total height is going to be equal to 3.1 plus 1.6, which is equal to 4.7 meters. Yeah, so this was an easy part. This is done. Okay guys, so we have the other part of this question, which reads: the man does not catch the ball as it falls. Your target is to calculate the time taken for the ball to fall from its maximum height to the ground. Okay, from its maximum height to the ground. Okay, so we require the time taken for the ball to complete this distance. Okay, so this is something that we require. This is the time that we require. So what we can do is that we already have the maximum height with us, which is S is equal to 4.7 meters, and we can proceed forward. The initial vertical velocity is kept at 0 because it is going to be dropping from this particular point, and what we have is the acceleration, which is going to be positive because the speed is going to be increasing. So I'm just using the normal approach. So there we have it. This is something that we have, and we can find the time. So S is equal to ut plus half at square. The value of S is 4.7. This is going to be 0 plus half times the acceleration is 9.81, and the time is something that we require, so this is going to be t squared. This is going to be 4.7 multiplied by 2 divided by 9.81, and we are just going to be finding the square root of this answer, and the value is somewhat equal to t is equal to 0.98 seconds. So this is done. This was the easy part. Now let's move on to the next part. The ball leaves the man's hand at time t is equal to 0 and hits the ground at time t is equal to t. Sketch the graph to show the variation of the velocity v of the ball with time t from t is equal to 0. Numerical values of v and t are not required. Assume that v is positive in the upward direction. So let's see. The initial vertical velocity that we had was 5.6. But we know this fact since it's going to be covering more distance upon return, so the final velocity is going to be larger. And we just need to draw a straight line. That is it, right? So numerical values of v and t are, assume that v is positive in the upward direction. We just need to draw a graph, and the graph is going to be shaped something like this. Let me just draw it. So let's assume 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the 10th marker over here. I'm just going to use this marker, and I know for the fact that the velocity is going to be larger because it is going to be covering more distance upon its return. So the velocity is going to be larger. So I'm just going to place a marker at almost the very end position. So the straight line is going to be somewhat like this. It's just going to be somewhat like this. Okay, so you can clearly see that the distance, the displacement is actually less initially compared with the final displacement from the top to the bottom. So this is something that you need to be very careful about. Okay, so this part is done. This is the 3-mark question. So this is state what is represented by the gradient of the graph. It gives the acceleration. The gradient gives the acceleration. It gives the acceleration due to gravity. Acceleration due to gravity, or simply the acceleration. The man now throws a second ball with the same velocity and from the same height as the first ball. The mass of the second ball is apparently greater than that of the first ball. Assume that air resistance is still negligible. For the first and the second balls, compare the magnitudes of their acceleration. Exactly the same. Exactly the same. No change. The magnitude of their acceleration, and as acceleration is equal to g, which is the acceleration due to gravity. This is for you. This information is only for you guys. Okay, the speeds at which they hit the ground, same, no change. No change. because the equations that we utilized or we used for solving this question does not have any reference to mass, so it won't change. Okay, so there you have it. This is done. This question is done. So the last question with us is this. Figure shows the horizontal beam clamped at one end with a block attached to the other end. The block is made to oscillate vertically. The Young modulus E of the material of the beam is given by this expression, where m is the mass of the block and t is the period of the oscillation, k is a constant. A student determines the values in the percentage uncertainties of k, m and t and lists the percentage uncertainties. The student used the values of this to calculate the value of E as this. Your target is to calculate the percentage uncertainty in the value of E. So we have the formula with us, which is E is equal to Km over T square. And since we have multiplication and division involved, we only need to add the percentage uncertainties. So let's just pull this off. And this is going to be, so percentage uncertainty in E should be equal to percentage uncertainty in K plus percentage uncertainty in M plus 2 times the percentage uncertainty in T. So let's find it out. So this is going to be 2.1 plus 0.6 plus 2 times 1.5. So the answer should be somewhat 2.1 plus 0.6 plus 2 multiplied by 1.5, and the answer is some 5.7%. So this part is done. Anyways guys, take care. So this completes the paper. This was an easy paper constructed so as to give you guys some confidence. Anyways guys, take care.